Hello guys, my name is Patrick Mensah, and I am going to talk about density estimation for continuous variable. So the problem that is associated with drawing histogram of continuous variable, they are much challenging. And then this has been a lot of issue for statisticians and data analysts. So, but God being so good, they have been able to write some books about it, about Canal density, which there is one man called Silverman who wrote a book about it in 1986. There is also another man called Scott, who has also written a book in 1992 about it. And then they have been able to do put it in our programming. So if you want to have a feel of it, we can use the density plots, the density function. So the density function to have a feel of it, and it gives you a kernel density estimation and everything over here. But that is not our focus. Our focus is on drawing a histogram to the histogram and see the challenges we will face about it. So regarding that, there is one thing called bandwidth, and this one is a compromise between smoothing enough to rub out insignificant bumps. So this bandwidth helps, but you see, when we have a bandwidth that is very, very low, it's become very bumpy and it doesn't have the fit. It doesn't have the fit. So what you have to do is to get a bandwidth that is between 0.5 upwards, 0.6 upwards. And there is a rule of thumb. So the rule of thumb for the bandwidth is by finding the maximum between the difference between the maximum and the maximum, then you divide it by 2 into bracket 1 plus the log of n, which is the length, divided by n to the base 2. I will show you how to do all of this. So let's keep it rolling. Now there is a library called math library, and we can find a lot of data sets in that. So we are going to use a data set that is called faithful, and that faithful data set is a data set that is containing an eruptions, the time of eruptions that happens between that happened in one of the states in the United States called Wyoming. I will show you how to do that. So let's keep it rolling. So we can call it for the library. So here on the computer, we call for the library, and then we call for the math library. Then we run it. Then we look at the faithful data. So what kind of faithful data I'm talking about? Let's look at it. We can use it. And here, like I said initially, it tells you the waiting time between eruptions and the duration of the eruption for the old faithful geyser in Yellowstone National Park, which happened in Wyoming, United States. Okay, I don't know how to pronounce this well, but that is not a focus. Let's focus on what we are doing. So we can have a view of the data by using the view function. So the view function is going to help you do that. So it tells you the time of the eruptions and then the time of the waiting time, which is this, and all these are numerical variables. They have 272 observations. So let's focus on what we are doing. Now let's work on that. We are going to use the rule of thumb. I will show you how the rule of thumb looks like and see whether it is good for us to use it or not. It's not good to use it. So what we have to do is to attach the data. So let's say we attach the data set. What kind of data sets are we using? We are using the faithful data set. So we attach it. And then now let's use the rule of thumb. So the rule of thumb is, like I said already, the maximum of the eruption, and then minus the minimum of the eruption divided by 2 into brackets 1 plus the length, which is we have 272 observations to the base of 2. And let's look at how it is done. This is very, very simple. So we can see that the maximum, the maximum of the eruptions. So the maximum of the eruptions minus the minimum of the eruptions. Then after you have done that, then you divide the whole by 2 times into brackets 1 plus the log of the length, which we know the length already. The length, sorry. Yeah, the log of the length. So let's say the length of what? Of the eruptions. Then after that, the length of it to what kind of base? I said to the base 2. So this is basically how we do the rule of thumb. Very, very simple. We run it and it gives us a value of 0.192573. We don't want that because it's going to produce too much bumpy effect. So we need a bandwidth that is like, let's say from 0.5, 0.6. That's going to make it better. So what we have to do is to draw our histogram. This is how we are going to draw a histogram. In our histogram, we want it to be on a single page so that we can actually do the comparison. So let's look at how we do that. So if you want to write 2 graphs on a same page, we use the MF par. We use this par MF row. Then let's say we create it like, okay, see, we want on only 1 page, and then we want 2 graphs. So if you want 3 graphs, you can do it. If you want 4 graphs on the same page, you can make it 2 by 2. So it tells you that 2 rows and the 2 columns. So but we need only 2 graphs on one page. So we do it like this. So this has already run. It's waiting for the graphs. So now what we have to do is to draw our histogram. So we draw our histogram like this. So our then our histogram, then we say eruptions, then we give it here we ask for the number of bins. So let's give the number of bins to be 15. Then another thing we can also do is to stop the frequency, because if you don't do that, it's going to produce a frequency. So we can stop it. So we can say frequency, then we say force. So force, okay, nice. Then another thing we can do is to call for the title, which is very, very good. So we say mean, then we say histogram eruptions. Let's say eruptions. Okay, so let's say Yamin eruptions. That makes it very simple. Yamin eruptions. This is the first one. Okay, one thing we can do is to also add colors to it to make it very, very nice. So I like using heat colors. So let's say I'm going to use heat colors, and let's say we're going to use 6. So we do that, and it produces this and over here. Very, very, very nice. Now it is waiting for the next graph over here. So, but one thing you have to do is to draw the Canal density. So one way of doing it is called the lines. So the lines and density of the eruptions, and then you can give it a width. The width is very, very important. So you give a width to it. So let's say the width is the bandwidth. So let's say we are going to choose 0.6. So we choose 0.6 for that, and then for how many values? So let's say n, which is let's say 200. Then let's run it and see. It's fixed over here. Very, very, very nice. I will explain this. let's draw our next this thing, and then we look at the differences. Our next graph. So our next graph, we are going to use something called a true hist, and that is gives us a true histogram. So it gives us a true hist. Then we say eruptions. Then the number of bins we are supposed to use. So let's say n bins. I mean, you can just write the bins, but I mean, like how I did it in the first one. That's like, I mean, I just wanted to know what's going on. So the number of bins is 15. Then let's say the color we are going to use is, let's use terrain colors, which I like that one too. This is 6. Then we can say the title is going to be, sorry, the main is going to be let's say true hist of main eruptions. Let's make it short. Eruptions. Then let's run that. It gives you something overnight here. Now we can also draw our lines, which we draw our lines like this. The density. Then you call for the eruptions. Then after you have done that, then you can call for the numbers. You can use the width, but I mean, you can choose to also ignore it. So let's give it the same number, which is 200. Then we draw it. Something nice here. Now let's explain. So now you can notice that though we use the bins that we use only 15 bins. Look at it over here. We use only 15 bins, but we actually got 18 bins. So you also know that although the histogram have 18 bins together, but they differ in the height of the several bars. So let's look at it. So when you look at the left histogram here, we have 2 peaks. Look at the histogram over here. We have 2 peaks over here, and then these 2 peaks are here. It is above 0.5. So look at it over here. 0.5 is here. All of these are above 0.5, while the true histogram has 3. So like yes, on the right it has 3, and also there is also a sub peak through the a sub peak of the true of the histogram that is above 0.3, but not on the true histogram, and so on. And these are some of the problems that we face in histogram. You also have to note that the default probability density curve on the right, this one, picks out the height of the peak through much less than our bandwidth, which is 0.6 on the left. So, I mean, these are some of the problems that we can find in histogram. So on this note, we call a docket on histograms. The next one, we are going to use box plot. And don't forget to subscribe to my channel. Thank you so much.